Okay, so today we're just talking about elimination. Sorry about that. So today's the elimination method. We've already covered the substitution method. And again, it's a three-step process. Okay, so step one is we're going to use multiplication on either one or both equations, okay, to obtain coefficients that differ only in sign. So what we're going to do is we're going to pick a variable to remove. Okay, instead of picking the variable to isolate, we're going to pick the variable to go away. We're going to multiply the entire equation by a number, so that way when we're done, we'll have like a 3x on top and a negative 3x on bottom. So if we were to add the two equations, the x term will go away. Everybody all right with that, yes or no? Okay, so that's what we're really saying here. We're going to multiply one or both equations by a constant to obtain coefficients that differ only in sign. So we want the exact same number on the variable in both equations, just one's going to be a positive and one's going to be a negative. Okay? Then we're going to add the two equations together after the multiplication. We're going to combine our like terms, and because we have either the x or the y with the same coefficient but opposite signs, one of our variables is going to go away. So when we're done, we'd better be able to eliminate one of our variables. And then we're going to solve for the remaining variable because we'll only have one left, and we know how to solve that, right? And then once we have the one known variable, we substitute the value back in, just like we did before, to solve for the remaining variable. Okay? So this one I like because, to me, the steps are not as truncated. It's a multiply, add, solve, back substitute. Okay? So it flows a little bit better, and to me it's easier to see what's going on than substitution, where you have to pull an equation out and do some heavy manipulation on it and then plug the entire thing back in. All right? But again, it doesn't matter which of these methods you prefer. What matters is that you know how to do them both, because when we get into solving 3x3 systems, we don't use that. We don't tend to use substitution on that. We tend to use elimination. Okay? But you need to be able to use both because, like I said, some situations substitution is better and some elimination is better. So because we're still solving a system, we're going to have the same situations where we can have one solution, no solutions, or infinitely many. Okay? And the result looks the same because we're still solving algebraically. So you should already have this written down, so I don't know if you need to write it down again. Okay, but I want to go back through it. This is exactly what I showed you for substitution, and most of you took notes on. All right, for one solution, that's when the variable stays around, right? So we're going to multiply, add, and after we add, there's a variable left, either x or y. Everybody okay with that? No solutions is when the variables go away, so we're going to multiply, and when we add, the x's and y's disappear. We get 0. All right. If we get something that is not a true statement, that's no solutions. If we get something that is a true statement, that's infinitely many number of solutions. So it's just like what we did with substitution, okay? Same rules are in play, and like I said, most of you took notes on this already. So you just got to remember, it's okay for the variables to go away. It doesn't mean you goofed up. Everybody all right? So just be careful. All right, so solve the following equation the following system by elimination. So what we're going to do is we're going to multiply the top equation and the bottom equation by different numbers, okay, by constants. But when we're done, we want to have the same coefficient on one of the variables, but opposite signs. So I want to know from you, which variable am I going to get rid of? Do you want me to get rid of x first, or do you want me to get rid of y first? X. Okay. So, I need a pen, please. Thank you, computer. So, I am going to multiply the top equation by some number, the bottom equation by some number, and I want to have the same value on my y, on my x, okay? So, what's the least common multiple between 3 and 4? 12. Okay, what do I have to multiply with 3 to get 12? Okay, so I'm going to take a 4 here. And what do I have to multiply with 4 to get 12? Ouch, there's a board there. All right. Now, what's 4? So what's 4 times 3? 3 times 4. Okay, they're the same coefficient, which is what I want, right? But remember, I'm going to add these, so I have to have opposite signs. Are they opposite signed right now? No. So that means that one of those numbers outside has to become a what? A negative. Okay, do you want me to put the negative on top or on bottom? Bottom? Okay. Does it matter? No, you'll actually get the exact same answers. Okay? So distribute the 4 on the top all the way through. So what's 4 times 3x? 4 times 2y. And then 4 times 11. Everybody okay with that? Yes or no? All right. What's negative 3 times 4x? Negative 12x. Negative 3 times y. Negative 3y. Negative 3 times negative 2. Positive 6. All right, so now what I'm going to do is I'm going to add these two results. And if you notice, what's 12x take away 12x? 0. So my x is completely gone, which is what you told me to do, right? So what I have to be darn sure of is when I multiply, one of my variables has the exact same numbers and opposite signage, 1 plus, 1 minus. Please be careful with that. A lot of you get into the habit of just canceling them off, and what I'll see is 12x and 12x. And you'll say, oh, 12x plus 12x is 0. No, that's 24. And what that means is that you missed a negative right here, and it's going to throw off your entire result. So all the work you're going to do is going to be wrong, okay, because of one sign. So again, elimination method is going to be particular, but what I like about it is that there's fewer steps than in substitution. It takes up less space, it's faster, and there's less opportunity to make sign mistakes. All right, so we add, you said 12 minus 12x is 0. What's 8y take away 3y? 5y, okay. And what's 44 plus 6? 50. All right, so now how do I get y by itself? Divide by 5, and so what's y equal to? 10. Everybody okay with that? So step 1 was the multiply. Step 2 is the add and solve for the one remaining variable. So how do you think I find x now? Okay, to what? One of the original equations, right? Again, doesn't matter which one? No, so which one do you want me to use, top or bottom? Bottom? Top, okay. So I take my top equation, I replace my y with my now known value. How do I get x by itself? Minus 20, so 3x is equal to negative 9. How do I get x by itself? So x is equal to negative 3. And again, just like always, I have to write out what my solution is. Solution is still going to be an ordered pair, and it's negative 3, 10. Everybody okay with that? So do you see why I like elimination? To me, like I'm not one of those math teachers like you guys know. I've never said that math is beautiful, right? To me, though, this is a lot prettier math than substitution method. Substitution is it's kind of like all over the place. Elimination is it's smooth. It's more refined. Okay? But is everybody okay with what's happening up here? Any questions at all? So it's a multiply, add, isolate, back substitute, you're done. Everybody good, yeah? Again, which variable do you want me to get rid of? X or Y? Doesn't matter which one I isolate first? Okay, but real quick, does it matter which one? No, so again, you need to develop your own system. Tell yourself when I'm doing elimination, I am going to remove this variable first, whether it's X or Y. Remove the doubt. Okay, build a system for you to work through. Everybody good? All right, so I'm going to get rid of Y. So what's the least common multiple between 5 and 10? 10, right? What do I have to multiply with 10 to get 10? 1, right? What do I have to multiply with 5 to get 10? 2. So now before I go on, I have to check my signage, right? What's 1 times negative 10? Negative 10, right? What's 2 times 5? Positive 10. So are they opposite sign like I want? Yeah. Everybody good with that? Yes, no? The cheap way of doing it is you either want 1 or 3 negative signs. So if you look, if I'm trying to remove y, I take the two numbers outside and then the coefficients on y, right? Positive, 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 negative. which is good, right? I only have one negative. So like I said, I either want one negative or I want three negatives. So now distribute, right? What's 1 times 4x? 1 times negative 10y. 1 times 18. Okay, 2 times negative 2. 2 times 5y. And 2 times negative 9. It is. So what do I do with these two? I add down, right? I perform what's called vertical addition. So what's 4x take away 4x? What's negative 10y plus 10y? What's 0 plus 0? So I get a 0 on the left-hand side. The x's are gone, the y's are gone. So I should already know what are my two possible answers. Either no solutions or infinitely many number of solutions, right? Because all the variables are gone. So whenever the variables disappear, it's either no solution or infinitely many number of solutions. Everybody okay with that? Okay. What's 18 take away 18? Is 0 equal to 0? Is that true or false? Infinitely many solutions. There's your answer. And we're done. So what's really important here is you got to make sure that when you multiply, you're distributing everything, including over the equal sign. Okay, notice how I set it up in parentheses where it's the entire statement. Make sure that you're multiplying every term by whatever you put outside. Okay? Everybody good? Yes, no, maybe? Any major questions on this? All right, then here's your homework. So, take a look at this, right? Tomorrow, you get to ask questions on substitution and elimination. Tomorrow is your one work day over both data sets, right? And I did 3 of the problems today from the last homework, so hopefully substitution we're okay with. So that's 3 points right there. Yep. So here is your elimination homework.